Sorry about that, the camera cut out. So I'm just going to go over a very quick example. I think I got through all the terms. This is example 11 in the textbook, and this is fairly straightforward. So let's say we have a top event given by the set of A, B complement, or AB. Okay, let's say we have this. What is the minimum minimal cut set here? So we can see just by inspection. So let's draw a truth table. Let's say we have so we have A here, we have B here, and we have A and B complement plus A, B. So all the permutations of this would be 0, 0, 0, 1, 1, 0, and 1, 1, right? So 0, 0, let's see, A and B are both 0. This is going to be 0 and 0 naught, that's 1, so 0 and 1 equals 1, or 0, so I'll just write that down, that's 1, or AB, so 0 and 0, that's going to be 0, that equals I'm sorry, I messed up. This should be 0 and 1, or the and operators. Both of them have to be true for it to register true. It's going to be 0, or 0 and 0 is 0, so that just the or operator between them is 0. Now we have here 0 and 1. So we have 0 and 0, that's 0, or 0 and 1, that's 0 again, equals 0. Now if we have A is 1 and B is 0, so we have 1 and 0 complement, which is 1, so 1 and 1 is going to be 1, or 1 and 0, that's going to be 0. The or operator is just going to be 1. So 1 and 1, then if A equals 1 and B equals 1, then or high or whatever, then we say 1 and 1 complement are 0. 1 and 0 is going to be 0. And the A, 1 and 1 is going to be 1. 0 or 1 equals 1, of course. So we can see here that it really doesn't matter what B is. It only matters what A here is. So long as A is true, then the expression is going to register true. So really our minimal cut set for this is just A, or A, where this implies that A equals 1, or just A it'd be notated like that. So the question is, how can we determine this without going through this truth table? And for a small expression like this, the obvious answer is just, well, we could expand this out, algebraically. We could say, factor out the a, and we have b complement plus b, and that just goes to identity. We have a, right? Simple enough. But this becomes very difficult when you have very large initial sets. So we can use something called a generalized consensus method. So I'm just gonna illustrate that with our top event that we're looking at. Let me just close my door. It's really annoying that this keeps going in and out of focus, so I have to fix that at one point. I wonder if I plug the slide in. Makes any kind of difference. Nope. Oh well, I'll fix this later. You can see it at any rate. So, in the generalized consensus method, what we're going to do is we're going to draw a table, right? And this table is going to have several columns. The first column is going to be the initial set. The second column is going to be the biform. The third column will be the residuals, and we're going to have a complementary residual column and a non-complementary residual column. Next column will be new consensi. The final column here will be the final set. Okay, and we get our initial set by just looking at the or separated terms on our initial expression, and we can see that we have the terms A and B complement here, and A, B, right? And we're looking for a biform variable, and if you recall from the description, the biform variable is just simply the variable that has both itself and its complement in the initial set. So we don't have A and A complement, but we do have B and B complement. So we're going to use B as our biform variable. And the residual, we have the normal residual and the complementary residual. And the residuals are just the initial set, the elements that contain the residual under inspection minus the residual variable itself. So for B, we don't have a B in this term, so we just ignore it. But we have a B in this term here, and so our complementary our residual here is just going to be A, and then our residual here will be for the complementary residual. We just look at here and we say A, B complement, and it's going to be A again. And we ignore this one because it doesn't have the B complement in it. Now, if you recall that there shouldn't be a complement sign there. The definition of the new consensi is the product of all the terms in the two residual columns. So A times A, you recall, is just A and A equals A. So our new consensi is just A. Now finally we're going to get the final set, and this is the union of the new consensi and the initial set. So we're going to have, and recall, the union operator is just the OR operator, AB complement, or AB, or A, okay? And we can just collapse this down algebraically, so now we simplify, and we get, we can factor out this A here. We have A times B complement, and B, and you recall that the complement of a variable and its normal form is just identity plus A. So this is 1. So that just equals A and A, which equals A. So our final set is just going to be A. And we're done now because there's no more biform variables in our final set. So we can say the top, which equals AB complement plus AB, simplifies via our general consensus method to just A. Simple enough. Now, let's go on to the more complex type problem. We're going to, let me just get this out of the way. We're going to look at the problem we did in class. I really need a bigger desk. I worked this out before, so I'm slightly cheating by looking at it. But the problem we worked in class was the top event equals the ABC, or the A complement B, or the B complement C, or the C complement A. Okay? We're going to use the generalized consensus method. You can see here that if we were trying to work this out algebraically, it's not so straightforward. So we're going to use the generalized consensus method to reduce this to its prime implicates. Oh, sorry, I didn't mention that this final set here, this final form, just A, that's the prime implicates, because that's the only term that implies complete system failure, the top event occurs. We don't care what B is. B can be 0 or 1, but if A is 1, then we get our top event no matter what. So let's set up our table again. So we have the initial set, we have the biform, we have the residual, we have it's complementary form, right? We have the put the residual separator here. I hope I can write that small. We have the new consensi, and the final set. In the textbook they have a little step column here, but I'm not going to use that. So our initial set for this problem is going to be A, B, Charlie, A complement B here, B complement C here, and C complement A. Okay? And let's just pick a biform. So